Morning. So today we want to start by doing the student evaluation. So there is a student evaluation in Moodle. I don't know whether you know how to access it. So we can do it within the next 10 minutes, and then we start the class. So you can even use your phone. So what you do, I don't know whether my screen can be seen. So you go to Moodle. So you log in. You know how to log in, right? So you just log in here. Then you go to your course. It's 1108. And then down here, to your right, there is feedback here. Okay, feedback. So you click there and then you do the evaluation from there. So you just click here and then you answer the questions over there. Those guys on Zoom, do you see my screen?
I don't see it, but I don't think it'll be terribly hard to find the feedback link.
Share my screen. Let me see if I can share my screen. Okay, so you can see it right now. So you go to your course here, and then you go to feedback down here. You can see that?
Yep.
So let me give you 10 minutes to do it, and then we continue. Those guys coming in right now, we are doing the evaluation. You go to your course and then you go to the feedback section. Then you click on there and then you answer the questions which are there. So you can finish it later if you're not done. So let's continue here. All right, so let's finish what we started last Wednesday. So we were graph quadratic functions using the transformation. So if we recall, so we say graph quadratic function using transformation. Using the transformation. So if we recall what we did, so we said we transform the function, the f of x equals to ax squared plus bx plus c into the form f of x equals to a, and then x minus h, and then plus k. By doing what? By completing squares. By completing squares. So we did an example on that. So let's do another example on this. And then we go to section 9.8. So the next example is example number 2. So example number 2. Graph the function f of x equals to minus 2x squared minus 4x plus 2 by using transformation. By using transformation. So we want to transform this into the form f of x equals to a, and then x minus h, and then plus k by completing squares. So our function is f of x equals to minus 2x squared minus 4x plus what? Plus 2. So how can we transform this function to this over here? So we do the completing squares. So I say, when you're completing the squares, so you make sure the coefficient of x squared is what? Is 1, right? So you make sure the coefficient of x squared is 1. So in this case, because we are not completing the squares that we did last time, here we only complete the squares on one side. So what you do here, you factor out the what? The minus 2 over here. So f of x equals to minus 2. So you separate the ones which have the x with the ones with the constant. So when you factor out minus 2x here, what will remain? X squared, right? And then here, what will be here? Plus, right? Plus 2x. And then plus the constant, which is 2 over there. Okay? So when you open these brackets, so what you get is minus 2x squared minus 4x plus what? Plus 2. Then now, let's complete the squares here. So f of x equals to minus 2 brackets x squared plus 2x plus, what do? You have the coefficient of what? Of x. You have the coefficient of x and then you square. So the coefficient of x here is 2. Half of this is what? Is 1. And then you do what? You square. So when you square 1, you get 1. And then plus 2. So what you do here, now if you open these brackets, when you open the 2 here, when you open the brackets here, yeah, the last constant here will be minus what? Minus 2, right? So what do you do here so that at long run, when you open these brackets, it will remove the one which is here? You do what? You add 2 in this side. So plus 2 there. Because when you open these brackets, then it will be, when you open these brackets, then it will be minus 2x squared plus minus 4x and then minus 2. And this minus 2, we want this one to be like our previous quotient here, our previous function here. So definitely what you do is you add 2 to the other side. When you add 2 and you come and subtract the one which is here, then it will be 0, right? So it will be like this function. So our function f of x now would be equals to what? Minus 2. So here it will be like what? So here it will be x plus what? Plus 1, and then you do what? You square, right? I don't know what it is. X plus 1 square, and then plus what? Plus 4. Okay? So plus 4 there. Now, so this is now the transform. We have transformed this one to be like that function there. So we have transformed to be like this. Okay. Now, how should we draw this graph? How should we draw this? So first, what you do is you draw the graph f of x equals to x squared. You start by drawing the graph f of x equals to x squared. And so let's do it in this side. So this thing is not into scale. You just, so long as it looks like symmetric, okay? So long as it looks symmetric. So because we're going to 4, so let me put here 1, 2, 3, 4. Then 1, 2, 3, 4. These are minus. Then 1, minus 1, minus 2, minus 3, minus 4, minus 5. So 1, 2, 3, 4 there. Okay. So you start by drawing the function f of x equals to what? X squared. F of x equals to x squared. So in this case, what can we, how can we draw this? So this is looking like this, right? So it is looking like that, okay? So this function is similar to x minus 0 squared, okay? So it is similar to this, okay? So if you get the axis of symmetry and the, what do you call? and the vertex. So our vertex here will be 0, 0. So that means our vertex will be at this point, and our graph will look like this. So this is the function f of x equals to x squared. Okay? Then our graph is like this. It is this, minus 2x squared minus 4x plus 2. So, and then now we draw the graph f of x equals to minus 2x squared equals to minus 2x squared. Okay? So, in this case, our a is what? Less than 0. So our graph will look like what? It will face down. But now, also, our symmetry, our vertex line is what? Is what? 0, 0. So our graph will look like this. So it will be like that. So this is our f of x equals to minus 2x squared. Okay? Then we are transforming. We go to the next. So our function is this. F of x equals minus 2x, x plus 1 squared plus 4. Okay? And then we are writing in this form. So our h in this case is what? Is what? Because here is minus h. So that means here will be what? Minus what? Minus 1, right? So if it is minus 1, then we go one step to the what? To the left. We go one step to the left. So in our graph, then this point now will transfer to this point. Okay? So it will transfer here. So this graph here will now transfer to this point. So that is our next transformation. Okay? So that is our next transformation. Then now we come to k. In our case, k is positive. Okay? So it is the same. This is the same as this. So our k is positive. Now, if it is positive, then our next will now transform 4 steps to the what? Up. So you go 4 steps up here. So this graph again will go 4 steps up. So this is 1, 2, 3, 4. And that is our final, how our final graph will look like. So this is our graph now, f of x equals to minus 2, x plus 1 squared plus 4. And this one is f of x equals to minus 2, x plus 1 squared. Okay? So the first one is f of x equals to minus 2x, which is this. The second one is f of x equals to minus 2, x plus 1 squared. And then the final one is this one. So it will transform to this f of x equals to minus 2, x plus 1 squared plus 4. So that is how we draw our quadratic function using the transformation. Are we together?
Do you have to draw all of them? Like if we have homework for this, you have to draw every.
Yeah, you draw all of them. It's a little bit, might take you a lot of time. I don't think this one might come in our exams, but I might set it in our exam 3. Okay? I don't think it will be, but make sure you read, make sure you understand. So the first transformation is this. So you should know if this one was positive here, if this one was negative, okay? So if this one is negative, then you should be able to identify how that will go by, okay? So you should be able to know. So if this one is negative, that means H will be what? Positive in our case, okay? So it will go to the left. And then if this is negative here, then it will go what? Down, 4 steps down, like what we did in the previous one. Any question? So one question can be that long. So it can be find the, so I said, a question can be like this. Identify parabola, how it will be facing. So that one can be one question. Number 2, axis of symmetry. That is another question. Number 3, vertex. That is another question. And then number 4, now draw the what? Draw the graph. That was the previous section. You now draw the graph. So before you draw the graph, then you need to get the x-intercepts and what? And the y-intercepts. You need to get the x and the y-intercept. And then now you're able to draw. Now, if you're given for the transformation, then you transform. Question can be like, transform this function into this. Another one can be, identify h and what? And k from this function. Okay? So you need to understand very well how to do this. So this is our formula. This is our formula there. All right, so let's come to section 9.8 if you don't have any question. Section 9.8. Hey guys, in Zoom, do you have any question?
No.
Now, section 9.8, solve quadratic inequalities. 9.8, solve quadratic . So in fact, this is almost our last. We only have one class, right? Which will be on Monday, which will be doing section 11.1 and I think 2. And then on Wednesday, I think review, and then we do our exam on Friday, exam 3. All right, so section 9.8, solving quadratic inequalities. So we know that our quadratic equation is like this. F of x equals to ax squared plus bx plus c. Now, our quadratic inequality will now be of the form ax squared plus bx plus c is greater than 0. Ax squared plus bx plus c is greater or equals to 0. Ax squared plus bx plus c is less than 0. Or ax squared plus bx plus c is less or equals to 0. So there are 2 ways of getting the interval notation here. So you can draw the graph, or you can use, you still remember what we did last time on how to get the interval notation of an inequality like this. Yeah? So what you do is you get the critical points. You remember the critical points? So those are the points which are giving you 0. So you make one side to be equals to what? To be less or equals to 0, something like that. And then now you get the critical points. So those critical points are the ones which are giving you 0, okay? So you get the critical points. So here, let's try to solve on how to use the graph. So the steps are the same, and then finally you identify the interval notation from the graph. So our graph is always like this: ax squared plus bx plus c. And the interval notations, the inequality is similar to this as well. Greater or equals to 0, f of x less than 0, f of x less or equals to 0, or f of x greater than what? 0. It is similar. Now, the graph of the quadratic function, f of x, this is always a parabola, okay? So it will give you a parabola. Either it is facing up or it is facing what? Down. Now, when ax squared plus bx plus c is less than 0, when ax squared plus bx plus c is less than 0, then this is similar to f of x is less than what? 0, because this is this function. So it is similar to this one. Now, if you're saying this one is like this, then that means we want to know when the parabola is below x axis, is below x-axis. So we want to know when the parabola is below x-axis. Now, if f of x or ax squared plus bx plus c is greater than 0, or f of x is greater than 0, then we want to know when the parabola is above. So we want to know when parabola is above y-axis. We want to know when the parabola is above the y-axis. So we have a diagram if you go check your textbook, there is a diagram which is showing you how it appears. So let's look at one example on this. So solve x squared minus 6x plus 8 less than 0 graphically. And write the solution in interval notation. write the solution in interval notation. So we know that this is a function of the form f of x equals to x squared minus 6x plus what? Plus 8. So the first step is you write this as a function like this. So this is our first step. Now, what you do what? You now get the what? The axis of symmetry, you now get the vertex line, the vertex, and then you get the intercepts, and then now you draw the what? Graph. So let's start by getting the axis of symmetry. So our axis of symmetry here would be of the form b equals to minus 2 minus b all over what? All over 2a minus b all over 2a. So we have our a equals to 1 and our b equals to minus 6. What am I doing? X equals to minus b all over 2a. So our x equals to minus b is minus 6. So that means it will be 6, right? All over what? All over 2, because a is 1. So, and x will be 3 there. So our axis of symmetry is 3. Then, let's get the vertex. To get a vertex, we now substitute the axis of the symmetry to what? To f of x. So f of x, so f of 3 equals to now 3 squared minus 6 by 3 plus what? Plus 8. So f of x, f of 3 equals to 9 minus what? Minus 18 plus 8. What do you get? So this is equals to, is it minus 1? Minus 1, right? Minus 1. So our vertex will be, what? 3 minus 1. So that is our vertex. Now, there's a step to jump. So how will this parabola, so it will be facing where? A is greater than 0. So it will be facing up like this. So that's how our parabola will be like. Now, after that, then we now get the what? The x and the y intercepts. So our function f of x equals to x squared minus 6x plus 8. Now our x, let's start by y intercept. So you let what? You let x to be equals to 0. So f of 0 equals to what? Equals to 0 squared minus 6 by 0 plus what? Plus 8. So our y-intercept is what? 0, 8. So this is our point in the y-intercept. Now, let's get the what? The x-intercept. The x-intercept. So our x-intercept will be what? You let y to be equals to 0. And this y is the same as what? F of x equals to 0. So x squared minus 6x plus 8 equals to 0. Then now we can use a factor method there. Our sum is minus 6 and our product is 8. So it's minus 4 and minus 2. So x squared minus 2x minus 4x plus 8 equals to 0. So x minus 2 minus 4, x minus 2 equals to 0. So x minus, using the zero product property, x minus 2 equals to 0. So our x equals to 4 or x equals to 2. So our x-intercept will be what? 4 and 0 and what? 2 and 0. So we have now the properties of drawing the what? The graph. So we have the axis of symmetry, we have the vertex, and then we have the y and the x intercepts. Now we draw. Okay, so this one is going to A. So we now draw this. So we can say this is 1, 2, 3, 4, 5, 6, 7, 8. Then minus 1, minus 2, minus 3, minus 4, like that. So the largest here is minus 1, minus 2, minus 3, minus 4. 1, 2, 3, 4, 5, 6, 5. So our axis of symmetry is what? Is 3, right? So our axis of symmetry is here. So that is our axis of symmetry. Then our vertex is 3 minus 1. Our vertex is 3 minus 1. So 3 and then minus 1. So it is where? It's over here. So over there. And we said this one is facing what? Up, right? Now, our y-intercept is what? Our y-intercept is 0, 8. So 0, 8. So this point here. So we can get another one. Because this one is symmetric, then how many steps to the axis of symmetry? 3 steps, right? So there are 3 steps to the axis of symmetry here. So these 3 steps, as we have another 3 steps to this point. So our next is what? Here. So 3 steps here, and then 3 steps to that point. So our next point here will be 6 and 1 and 8. 6 and 8. Then our x intercepts are 4, 0 and 2, 0. So 4, 0 is here. 2, 0 is here. Now, how should we draw our curve? So it is starting from the vertex, which is here, and then it goes this way and that way. And then it goes again here, through the here, goes that way, through that one, like that. Okay? So that's how we draw that. Then now, so those are a lot of marks. If you're able to do up to there, those are really a lot of marks. Then our function, our inequality is what? What is our inequality? So our inequality is x squared minus 6x plus 8 less than 0. So for you to make this, to get the interval notation easily, then you can identify a point at the x-axis, yeah, at the x, where it will agree with this, okay? Where it will agree with this. Now, if we try this point, when x is, so that means in this case, we are not including what? x2 here, right? X equals to 2, or x equals to 4, because it will give us equals to what? 0, okay? So if we try this point, x equals to 1, if we try the point x equals to 1, will it be less than 0? So let's try the point x equals to 1. So this is 1 square minus 6 plus 8 less than 0. Is this less than 0? So this is 1 minus 6 plus 8. Is it less than 0? It is not, right? Because this is 1 minus 6 is 5. 5 plus 8 is, minus 5 plus 8 is 3, right? So 3 is not less than 0. So we are not including that place. Then again, if you try 5, then it will not include that. So therefore, our interval here will be what? 2 and 1, 4, but we are not including 2 and 4. Okay? So this is our interval notation. We are not including 2 and 4. They are within 2 and 4, but we are not including 2 and 4. So those are the points below the what? Below the y at the x-axis. So these are the points below x-axis. Any question up to there? Okay, so because of time, we will, on Monday, we'll come and do one example on this, and then we finish the book. Okay? All right, so before you leave, guys in Zoom, do you have a question?
No.
So before you go home, let me take the attendance here. Avalos, Benjamin, Gregory, are you there? Ashley, Victoria. Victoria, are you here? Rachel. Rachel, you're online, right?
Yep, I'm online.
Bailey. Laura. Adam, I can see you there. Kavehi. Andrew.
Here.
Andrew, online, okay. Destiny. Abby, are you online? Aliyah, are you online?
I'm online.
Ledesma, Jillian, Remington,
Here.
Midon, you're here. Rayleigh. Eric, I can see you there. Kayla, Rock, Thompson, Samuel, and then Walkman. All right. See you on Monday, and make sure you prepare for your exam, which will be on Friday next week. You too. Mhm.